Alright, good afternoon everyone. Today is Thursday, March 17, 2022, and we will be discussing about decision control structure of a flowchart. So what is a decision control structure? So a decision control structure is a type of a flowchart that needs, if you have a decision to make in a programming, so you will use this type of structure. So our target is, by the end of this learning guide module, the student should be able to identify computational problems that require decisions. Second, design logical solutions for computational problems that requires decision in a flowchart using Flowgorithm. In the previous module, you learned to make flowcharts that show sequence of steps in solving problems. However, there are situations wherein the subsequent steps are determined by some conditions. For example, the solution to determine which of the two given numbers is greater. Or another example is how to determine whether a number is odd or even. So the flowchart of the algorithm in the two given examples involves steps that are based on condition. If you look at the figure, the decision presents two alternative branches. However, only one branch is taken depending on the outcome of the condition. The diamond here represents a splitting point or a decision. Lines coming out of the diamond leads to a various sub-process as shown in this figure. The condition in the decision symbol must be a Boolean expression. What is a Boolean expression? These are expressions that results to either true or false. If the condition is true, then the true branch is taken. Otherwise, the false branch is taken. For this reason, it is important to label the branches accordingly as shown in figure 1 and the succeeding examples therein. Recall the first example. The steps to determine in which number is greater is shown in this flowchart. So we have declared numbers n1 and n2 as integer. Then we have input n1, input n2, and then we have the decision here. So the decision or the condition here is if n1 is greater than n2. If the result of the condition is true, then output the first number is greater. Or if it is false, output second number is greater. Within the decision symbol, the value of the variable n1 is tested if it's greater than n2. If greater, the true path is taken and the phrase first number is greater is printed. Otherwise, the false path is taken and the phrase second number is greater is printed. For the second example, determine if the given number is odd or even. The flowchart is shown here. So the flowchart or the algorithm here asks the user to enter a number, then determine whether the number is odd or even. So here we have the flowchart, which shows that the number is an integer and we have an input called number. Then we have the condition in which the number is divided by 2, that it should have a remainder which is equal to 0. So if the number is true or the condition is true, meaning the remainder is 0, output the number is even, or if it is false, output the number is odd. So in the flowchart from the previous slide, it showed that after the number is entered and is known, it is tested whether it is odd or even by getting the remainder when the number is divided by 2. If the remainder is equal to 0, the message number is even is displayed and the algorithm ends. Otherwise, the number is odd is displayed and the algorithm ends. So only one condition is satisfied for any given number. Then the percentage symbol in the expression number %2 is equal to 0 represents the modulo operator. The modulo operator returns the remainder when the operand on the right is divided by the operand on the left. Thus, the expression number modulo 2 implies what is the remainder when the number is divided by 2. Though percentage is commonly used to represent the modulo operator, every programming language has its own symbol. In the case of Python, C++, or Java, the modulo operator is represented by the % symbol. So if you have no more questions, I would like to thank you for attending our session this afternoon. Thank you and have a nice day. Bye.